Alright, this review, the first few minutes, I'm just going to be finishing up some examples that I needed to do for part one. Just want to make sure you guys understand the concepts by working out some examples. And then I'm going to do the part two review immediately following that. So let's go ahead and get started. As you'll recall, I told you in Class Connect that you must take the exam on January 14th and that the exam's going to be locked before and after that date. And you will be allowed to use your notes and textbook on the exam. Please do not be browsing through the internet while you're taking the exams or using answers you may find on the internet, because if it's suspect that you got your answer from the internet, you will automatically receive a 0 on the final, and we don't want that to happen. Okay, I just picked up from where I left off in Class Connect, and this was the next example. I couldn't quite remember if we had covered this one or not, so let's go ahead and go over it now, because either way will be good. Okay, I'm supposed to determine if this statement is true or false, and the statement says EFGH is a square, therefore EG must be perpendicular to segment FH. So I'm going to look and see where EG is, and that's the diagonal, and it says that it's perpendicular to FH. If that's true, then that means those are all right angles, and I know that is true because if I look at the properties for a rhombus, those properties say, let me write that out here, for a rhombus, one of its special properties says that diagonals are perpendicular. And recall that a square has all the properties of a parallelogram, has all the properties of a rectangle, and has all the properties of a rhombus. Therefore, this statement is true. Okay, for this it says for parallelogram EFGH, determine HG. When they say determine HG, we're going to bet that they're wanting us to say what the length is of HG. Well, they're telling us that the measure of angle FGH is 40 degrees. So FGH, that would be this whole angle right here, is 40 degrees. You can't see my marker very well. So that also tells me this angle over here is also 40 degrees. Just can't see it on that orange. Now they tell me that segment EF is 12 centimeters and that EJ, oh, that would be half the diagonal, is 4 centimeters. Okay, well, all I have to worry about is HG, which is this distance right here. And if you'll remember, your properties of a parallelogram say that opposite sides are congruent. Therefore, I know that EF equals HG. If EF equals 12 centimeters, then HG has to equal 12 centimeters. Okay, this says for parallelogram EFGH, calculate the measure of angle GHE. So let me find out where that's at. Oh, that's this one right here. I'm going to change my pen color right quick. Okay, let me come back over here. There we go. That whole angle is what we're looking for. They tell me that the measure of angle FGH, so that's this whole angle right here, is 40 degrees. Oh, this is still the same as that other one. So 12 centimeters, and then EJ is 4 centimeters. Okay, now if you'll remember, another property of parallelogram says that consecutive angles are supplementary. I'm going to run out of room. There we go, supplementary. So that means that the measure of angle FGH plus the measure of angle GHE equals 180 degrees. So I can just plug in what I know, and I'm going to use X so I don't have to write that out. So I just subtract 40 from both sides and I get 140 degrees. So the measure of angle GHE equals 140 degrees. Now this is a good example of why you never go by what the picture looks like, because this is obviously an acute angle, this is obviously an obtuse angle, so those degree measures aren't matching what those angles look like. So never assume anything by looking at the picture. Okay, this says triangle ABC is congruent to triangle DEC, and then they give us all these measures. They say, what is the measure of AC? And they've highlighted it there for us. So when I have these, I like to go through and figure out what I know, or what they're giving me. They said this one, AB equals half the measure of AC, said BC equals 12, DC is this right here equals 9, measure angle A is 40 degrees, measure angle E is 60 degrees. Ooh, so that means that angle B is going to be 60 degrees, D is 40 degrees, so I'm not dealing with any kind of special triangle. Oh, okay, I see now. So the side opposite the 60, see how DC is opposite E, and it's going to be 9. So AC is opposite angle B, so it's also going to have a measure of 9. So we're going to say AC equals DC. So AC is going to equal 9. Okay, same thing. Now they want to know the measure of angle C. I'm not going to do all that. I'm just going to do the angles this time. I know this is 40. That's 60. I know angle E is 60. No, angle D is 40. So to figure out this measure right here, I use that triangle sum theorem. And remember, that is telling me that the measure of angle D plus the measure of angle E plus the measure of angle C is going to equal 180. So D is going to be 40, E is 60. I'm going to put an X in there for C. So I get 100 plus X equals 180. Subtract 100 from both sides, and I get 80. Now you probably could have done some mental math and figured that one out pretty easy. So the measure of angle C is 80 degrees. Okay, determine whether the triangles are congruent, and if so, choose the postulate that proves they are congruent. It says triangle ABD is congruent to triangle CBD by which one of these theorems? Well, if you look, they don't tell us anything about the angles at all. Okay? They do tell us that CB is congruent to AB, which are corresponding sides. They tell us that CD is congruent to AD. Those are corresponding sides. And then I know that BD is congruent to BD, and that's because of, I can't remember what it was called. Oh, it's the property. Reflective property. Property of reflection, something like that. Okay, so side, side, side. I know a lot of you would like to assume, and I stress the word assume, that those are perpendicular right there, but we can't, okay? Unless the problem tells us those are right angles, we can't assume anything. So we don't know anything about the angles there. Okay. I can't find my pointer. There we go. All right. This one says, determine whether the triangles are congruent. If so, choose the postulate that proves they are congruent. It says triangle LMN is congruent to triangle KJN. So, now when I see the corresponding sides that are kind of in angles that are laid out like this is where I like to label them. I label this one side, angle, side, side, angle, side. So that tells me by, or what postulate to use. So it's going to be side, angle, side. Let me see, they're telling us these triangles are congruent. I'm going to do the same thing, just label. There's angle, side, angle. And I'm just doing the corresponding angle and side on the other triangle. So there's my answer there. Now this one's a little tougher. They tell us that they're congruent, but I'm not quite sure how until I start looking at it a little closer. I do know that I have these angles right here, and I'm just putting A for angle. Alright, but it's also showing me that AF is parallel to DE. It's also showing me that EB is parallel to FC. Therefore, since DA is a transversal that cuts through those, I know that AF is also congruent to DE, and I know CF is congruent to EB. And then, like I said, the reason I know that is because DB is a transversal. Okay, and I also know that DB is going to be congruent to itself as well. So that doesn't really help me in my answer, but I do know that fact. Oh, so let me go in here. So I got side, 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 side. Okay, it says, what is the circumference of a circle with a radius of 11? Well, there you got to get out your geometry formula chart, and you got to remember that to find the circumference of a circle is c equals 2 pi times the radius. So my circumference is going to be 2 pi, and then my radius is 11. And if you'll notice, they included pi in with the answers. So 2 times 11 is going to be 22 pi, and then it's meters. So that's my answer. So I circle the fourth choice. This one says, what is the measure of angle x in degrees? Well, here I have an isosceles triangle. So that means that my base angles are congruent. Oops. Base angles are congruent. Alright, so if my base angles are congruent, that means angle R is also 47 degrees. You got your triangle sum theorem that says the measure of angle Q plus the measure of angle R plus the measure of angle S equal 180 degrees. So I got 47 plus 47, putting an X in there for S. 47 and 47, I believe that comes out to be 94. And then 180 minus 90 is going to give me 90, minus 4 give me 86. There we go. So the measure of X, or the value for X in degrees, is 86 degrees. Okay, this says what kind of parallelogram has diagonals that bisect each other? Well, we know that a parallelogram, if we look at the properties, that the diagonals bisect each other. So we can say all parallelograms. Then we know that a rectangle shares the same property. We know, and that's incorrect, that should say rhombi, that rhombi also have diagonals that bisect each other, but we know that trapezoids do not. So our best answer choice right here is going to be all parallelograms. Okay, what is the length of segment DE? Well, when we look at this, we're looking at a mid-segment of a triangle. And you remember, mid-segment of a trapezoid, mid-segment of a triangle, I just said you're adding bases and dividing by 2, except the special thing about a triangle is it only has one base. So we're going to take the base, divide by 2. So that means I have 16 divided by 2 equals 8, which equals the measure or the length of segment DE, 8. So that's your answer. All right. It says, what is true of isometric transformations or isometries? It says dilations are isometries. A reflection is not an isometry. All isometries preserve congruence. Rotating a figure 180 degrees is the same as reflecting across a line. Well, first you have to remember, what does isometric mean? Isometric means that preserves congruence after transformation. Oops. Okay, so dilations do not preserve congruence. A reflection is an isometry, and I'm liking this answer right here. And rotating a figure 180 degrees is the same as reflecting across a line. That's true, but it doesn't have anything to do with isometries, and it's only true I believe in certain situations. I think it kind of depends on the shape, but anyway, your best answer there is all isometries preserve congruence. Alright, what is the area of a parallelogram? What is the area of the parallelogram in square units? Well, you have to remember that to find the area of any quadrilateral is length times width, but sometimes we refer to it as base times height. And in this parallelogram, your base is 11 and your height is 4. Okay, this right here is a slant height, which doesn't count as the height of the parallelogram. So I'm going to have 11 times 4, which is 44 units squared. And our last example is going to be, what is x in this triangle. Okay, you can use the Pythagorean theorem, but if you'll recall the 30, 60, 90 triangle, it tells us that we're always going to label the side opposite the 30 degrees. We're going to label that x. The side opposite the 90-degree angle is always 2x. The side opposite the 60-degree angle is always x root 3. I know that's kind of confusing because they already called that x, but it's all going to work out. Because all I have to do is take this 5 right here and plug it in for this x. So I get x equals 5 root 3. Now granted, that didn't seem like it was shorter than the Pythagorean theorem, but if you know how to label your 30, 60, 90, you could have figured out that answer in like just a couple of seconds versus taking all the time to work out the Pythagorean theorem. Okay, I'm going to go ahead and stop this video for the examples from part 1 of the review, and I'll start a new recording for the part 2 review. Thanks for listening.